For the last section of 2.3, they want us to put together everything that we've already talked about in terms of properties of functions in order to graph a function, okay? So we're gonna go step by step. Let me refresh your memory using the directions. They said for each of the following, they want you to find the domain. Remember, for domain, you're looking for places the function does not exist. So that could be, in the case of like the first one, that could be a place where the denominator equals 0, right? The same thing for B. With the piecewise functions down below on C, D, and E, that could be places where the two pieces of the function, remember, they don't meet up. So things like that, okay? So that's what you're looking for that. In behavior, you're gonna check your horizontal asymptotes, okay? So you're gonna check horizontal asymptotes. X-intercepts, for an x-intercept, you either set y equal to 0, or if you're dealing with a rational, you want the top to equal 0, okay? A y-intercept, you're gonna plug x equals 0 in. Symmetry, we're gonna check negative x. And then all of the discontinuities that we found using whatever method of finding discontinuities is we can find. So that's particularly gonna happen when we're dealing with the piecewise functions, okay? So let's start with A, here we go. So they want us to find all of these things about this function. Well, the first thing I'm gonna do is try and factor this guy out, okay? Because I know that if I can get it into its separate pieces, then I'll be okay. So let's look at the top. The top I know I can take out a 2. That leaves me with x squared minus x minus 2. And x squared minus x minus 2 factors to x minus 2, x plus 1. Okay, and let's look at the denominator. The denominator, I can take a 3 out. So this is x squared plus 9x, x squared plus 3x minus 10. Okay, and so that factors to x plus 5 and x minus 2. Okay, so now we've got him set up in a way that I can use to find all of these other pieces. So looking at the domain, just doing the domain of this function, I know I'm going to have issues in the domain anytime the denominator equals 0. Well, this denominator is going to equal 0 when x is negative 5. So x cannot be negative 5 and x cannot be 2. Okay, because that would make this one 0, that would make this one 0. So x cannot be negative 5 or 2. Remember, you could also write that this way with the union symbol. And either way you want to write it is totally fine with me. It's just going to depend on if you're dealing with a multiple choice question so that you would have to see which form they want it in. So other than that, whichever form you want to write it in works for me. I would probably, honestly, if it was me, write it in this form just because there's less to write. But whatever makes you happy. Horizontal asymptotes. Remember, for horizontal asymptotes of rational functions, you're looking for the exponents. So this exponent is a 2. This exponent is a 2. They're the same. So that means the horizontal asymptote happens at the coefficient. So the horizontal asymptote is at y equals 2/3. Okay? So that's in behavior. The x-intercepts, remember when dealing with a rational function, the x-intercepts happen where the two factors on the top that are not wholes equal 0. Well, this guy right here, x minus 2, that's a whole. Okay, so that's not going to be one of the x-intercepts, so make sure you're recognizing that. So that just leaves me with this one, and this one equals 0 where x is negative 1. So I have an x-intercept at x equals negative 1. Okay, I have a y-intercept anytime I plug in 0 for the x's, whatever I get for that. So if I plug 0 in for the x's, I'm going to actually do that. So if I plug 0 in for this x, I get negative 2. If I plug 0 in for this x, I get 1. And on the bottom, I still have the 3. If I plug 0 in for this, 0 plus 5 is 5. If I plug 0 in here, 0 minus 2 is negative 2. Okay. The top, I get negative 4. And the bottom, 3 times 5 is 15 times negative 2 is negative 30. And these guys both reduce. First of all, they're both negative, so that cancels out. And then they both reduce by 2, so this is 2/5. 2/15, and it's a y-intercept, so I'm going to put equals y. So the y-intercept occurs at 2/15, okay? And then any symmetry, that's where I'm going to change the signs to negative. I'm going to do that in this part of the function just because I think it's easier to see. So we'll check symmetry by doing f of negative x. So this is 2 times negative x squared minus 2 times negative x minus 4 over 3 times negative x squared plus 9 times negative x minus 30. All right, so looking at each of these pieces, this first piece right here, the 2 negative x squared is going to be 2x squared because it's an even power. This one, negative 2 times negative x, changes to positive 2x, and that's minus 4. So on the top, I've got one that stayed the same, one that stayed the same, and then this guy changed signs from the original. So we've got same, opposite, same. So we've got a mix of weird things happening. So I don't even really have to do the bottom. This doesn't have symmetry at all, so neither. It is not symmetric. So you can either write neither or you could write no symmetry. Okay, either one of those would be correct. All right, and then they want me to graph it and label all of the discontinuities. Well, the discontinuities that we're dealing with is the whole, okay? We're gonna have a whole at x equals 2 because that's where my factors are the same, right? They're both the x minus 2's. So there's a whole at x equals 2, and I have an asymptote at the factor on the bottom that is not included on the top, so I have an asymptote at negative 5. Okay, so with all of that information, I should be able to graph this thing if I left myself space. So let's graph it over here. We'll graph it kind of small. Let me move it over a little bit more because I've got to get negative 5 on there. So here we go. All right, so 1, 2, 3, 4, 5. Let me zoom in a little bit on what I'm graphing. Sorry about the shaking. Okay, so zooming in on that. At negative 5, I have an asymptote. Okay, actually, let me graph this on a separate sheet of paper. It'll be easier for you to see. Okay, bigger graph. There we go. That's way better. Okay, that's way better. All right, so 1, 2, 3, 4, 5. So at negative 5, I have an asymptote. And we're just sketching a graph, right? It said sketch a graph, not make sure your graph is completely accurate, but sketch a graph. Okay, so I'm gonna just put the things that I have. I have a whole at 2, but I don't know where it's gonna be yet. I have an x-intercept at negative 1, okay? At 2, I have a hole, so 1, 2, there should be a hole. Okay, I'll put that on there in a second. I have a horizontal asymptote at 2/3, so that's here-ish. Well, that's a little more than 2/3, but that's okay. We're sketching, right? Horizontal asymptote at 2/3. What else do we have? The x-intercept is negative 1. The y-intercept is 2/15, which is like barely above 0, so that's about there. Yeah, and that's all we've got. So, and we know it's not symmetric, which if you look at where these asymptotes are, you should be able to tell that it's not symmetric. So I know that rational functions exist in 1 or 2 of these. So it's either in these 2 or these 2. Look at this one where these points are though. So this graph is going to come in here through this. And as it's coming in here, there's going to be a hole. And it should have this asymptote. Okay, so it should look something like that. Okay. If I plug in something to the right of this, so if I plug in something like negative 6, look what's going to happen on the top of this function. Let me get where you can see it. If I plug in the negative 6, this 2 is always going to be positive. This term will be negative. This term will be negative. So the top is positive. So positive times positive, negative is positive. If I plug in the negative 6 to this one, I get a positive, a negative, and a negative. So that's positive again. So that tells me it's in this top quadrant. So it's going to be up here. So my graph should look something like this. There's a sketch of the first graph.